Assalamualaikum and good morning. Today we would like to present angular motion. I am Wafa Widat and my partner is Siti Shawanis. Introduction. The angular motion can be described as the body moving along the curved path moving at consistent angular velocity. The motion of the body around a fixed axis or point can be defined as the angular motion related to that body. In this slide, we will introduce the concept of position, displacement, velocity, and acceleration.
Angular displacement measured in revolution, degree or radian. 1 rev equal to 360 degree equal to pi radian. The best measure for the rotation of rigid body is a radian. Angular velocity is the rate of change in angular displacement, radian per second. If a point on rotating shaft that takes time to rotate through an angle, then the F is omega equal to V per R, angular velocity in radian per second. Angular acceleration is defined as the rate of change of angular velocity with time. The symbol for angular acceleration is alpha and the unit is radian per second square. If the angular velocity of a rotating object change from omega 0 to omega 1 in a time interval of t, then the average angular acceleration during that time interval is average acceleration alpha equal to omega 1 subtract to omega 0 per time. Functionality and application. Functionality. The concept of rotational acceleration, angular velocity, angular displacement, rotational inertia, and other topics discussed in this chapter are useful in describing the operation of running in a circular track. Application. Running a racing on a circular track in a car, bike, cycle, or by feet involve the action of angular motion. The person or the vehicle travel at a certain velocity around an axis. It is considered to be essential to retain a suitable angular momentum to elude the happening of any form of accident.
Types and categories. Displacement, velocity, and acceleration are defined in the same way for angular motion as for linear motion with two slight differences. Displacement. In linear motion, we use s to quantify the linear distance traveled. In angular motion, we use theta for the same to quantify the angular distance, and it is measured in radians. Velocity. In linear motion, we use v to denote velocity, while in angular motion, we use omega to indicate angular velocity. Velocity. Angular velocity is the number of radians covered per second. Acceleration. We use a to denote linear acceleration, while we use alpha to mean the angular acceleration. The unit for angular acceleration is radian per second square. Torque and angular motion. Torque, or the moment of a force about an axis, is defined by T equal to Fr. A particle of that body at A rotates through a turning circle of radius if F is the tangential force acting on this particle at A. Then using Newton's second law, we have the total torque acting on the body is the sum of the torques acting on all these small particles. Thus, what torque has to be applied to a flywheel with a moment of inertia of 30 kg to give it an angular acceleration of 0.5 radian per second square. Torque equal to inertia times 2 alpha. study with solution 1. The block is lifted from rest until the angular velocity of the drum is 16 radian per second. After a time of 4 seconds, what is the average angular acceleration? Alpha equal to omega 1 subtract omega 0 per times. So 16 divide 4. Alpha is 4 radian per second square. Case study with solution 2. A wheel initially at rest is subjected to a constant angular acceleration of 2.0 radian per second square for 50 seconds. Calculate the angular velocity attained and the number of revolutions the wheel makes in that time. Since omega 1 is omega 0 plus alpha times t, and the omega 0 is 0 radian per second. So the omega 1 is 100 per radian per second. Since theta is omega 0 times t plus 1 per 2 times alpha and times t square. So theta is 2500 radian. The number of revolution is 397.9. Case study with solution 3. A wheel initially has an angular velocity of 50 radian per second. Brakes are then applied and the wheel comes to rest in 15 seconds. What is the average retardation? Since omega 1 equal omega 0 plus alpha times t, so alpha is negative 3.3 radian per second square.
From the measurement of the calculation, angular velocity, angular displacement, and angular acceleration are related to calculate omega, alpha, torque, and time taken. Displacement, linear motion is S, angular motion, theta. The relationship is taken equal to r theta. Velocity, linear motion V, angular motion, omega. The relationship is velocity equal to r omega. Acceleration is A alpha. Angular motion is alpha. Relationship is alpha equal to. That's all from education.